There is a plateau in the American Southwest that has stood for what geologists estimate to be 60 million years. It rises from the desert floor in a nearly perfect rectangular form. Its walls are vertical, not sloped, not eroded into curves, not tapered by wind. Vertical. Its top surface is flat. Not approximately flat. Flat in the way a table is flat. Flat in a way that makes trained engineers stop walking and stare. The official explanation is erosion. Differential erosion, the process by which harder rock resists weathering while softer surrounding material wears away over geological time. The mesa stands, we are told, because it was always harder than what surrounded it. Nature carved it. Wind shaped it. Rain and frost and 50 million years of patience produced what you see today. But here is where the story breaks. Because when you look at the angles, when you actually measure the geometry, you find something that erosion does not explain. You find right angles preserved at scales that natural processes do not prefer. You find flat surfaces at elevations that match each other across hundreds of miles of separated terrain. You find evidence of vitrification, the fusing of rock surfaces under extreme heat at sites where no volcanic activity has been recorded. You find tool-like striations in stone that predate any known human civilization by orders of magnitude. You find, in other words, a pattern. And patterns do not occur by accident. What you are about to hear is not a refutation of geology. It is something more unsettling than that. It is an examination of the geological record itself, of what the rock remembers, of what the measurements reveal, and of what the official framework has consistently failed to explain with any precision. The mesas that look cut. The formations that shouldn't exist as natural remains. This is where we begin. Part 1: The Geometry Problem. In 1869, John Wesley Powell led the first documented expedition through the Grand Canyon by river. He was a geologist. A serious man. A man who had lost his arm in the Civil War and still chose to navigate unknown whitewater in wooden boats because he needed to understand the earth beneath his feet. Powell documented everything. Rock strata. Elevation changes. The color and composition of canyon walls. He produced records that became foundational to American geology. And in those records, buried between careful scientific observations, he wrote something that has never been adequately addressed. He noted the presence of what he called architecturally regular formation structures within the canyon walls that appeared, in his words, to possess an orderliness inconsistent with the chaotic nature of water erosion. He did not pursue it. He had a river to survive. But he wrote it down. That observation, architecturally regular formations, is a thread that runs through the geological literature of the American West for the next century and a half. It appears in different language, under different names, documented by different observers in different decades. And it is consistently minimized. Consistently filed under interesting anomaly. Consistently explained away with the same elastic vocabulary that natural science reaches for when its models don't fit the evidence. Differential erosion. Columnar jointing. Frost wedging. Chemical weathering. These are real processes. They produce real formations. No serious person disputes that. But they are also terms that have been stretched, applied beyond their mechanical limits to cover formations that, by the physics of those very processes, should not exist in the form they take. Let us be precise about what we are looking at. A mesa is, by definition, an elevated flat-topped landform with steep sides. The word is Spanish for table. They are common across the Colorado Plateau, across the Sahara, across the Karoo of South Africa, across the Parana Basin of South America. Every inhabited continent has them. Every geological survey has catalogued them. The standard formation model works like this. A region of layered sedimentary rock experiences uplift. Tectonic forces push the land higher over millions of years. Erosion then attacks the exposed surface. Harder caprock, typically sandstone, limestone, or basalt, protects the material beneath it. The surrounding softer rock erodes away. What remains is the mesa, the protected column, standing where everything around it has been stripped to a lower level. This is coherent. This is demonstrable. This happens. But the model has load-bearing assumptions that are rarely interrogated in popular geology, and when you interrogate them, the ground shifts. Assumption 1. Erosion is isotropic. That is, it operates in all directions with roughly equal force over geological time, so formations are shaped by the statistical average of all erosive pressure. Random inputs produce rounded outputs. Mountains are not cubes. Canyons are not corridors. This is what the model predicts. And yet the mesas of the Colorado Plateau are not rounded. They are angular. They have corners. Not approximate corners. Corners that approach 90 degrees when measured with modern surveying equipment. Corners preserved at heights of several hundred feet. Corners maintained across vertical drops where frost wedging and thermal expansion, the very processes that should have rounded them, have had 60 million years to operate. Assumption 2. The flat top is a function of caprock resistance. The hard layer protects what is beneath it, so the top remains at the level of the original caprock. Flat top, the model says, equals resistant cap. But the caprock theory has a mathematical problem. To produce a flat surface at the scales we observe, surfaces extending across square miles, you need the caprock to have been uniformly resistant across its entire area. Not mostly uniform. Not statistically uniform. Uniformly resistant. Because a single zone of weakness allows water infiltration, allows undercutting, allows collapse. A single low point in a mesa's surface becomes a drainage channel, which becomes an erosion vector, which eventually destroys the flatness. The Meseta de los Cantos in the Spanish interior has a flat summit surface extending over 400 square kilometers. The Roraima Tepuy in Venezuela, perhaps the most famous flat-topped mountain on Earth, rises to over 2,800 meters and maintains a summit plateau of approximately 30 square kilometers with vertical walls exceeding 1,000 meters in height. Both are ancient. Both are explained by caprock resistance. But when you drill into the caprock of these formations, when you take cores and analyze the composition, you find variations. You find zones that should have been weaker. Zones where, by the model's own logic, erosion should have found a path. Zones that remain inexplicably intact. This is not a secret. It is in the literature. It is noted, briefly, and moved past. We are not moving past it. Part 2. The Vitrification Record. In 1947, a geologist named Virginia SteenmcIntyre was working in the Geological region of central Mexico. She was dating an archaeological site, a standard professional task. She used multiple independent dating methods: zircon fission track analysis, tetrahydration dating, uranium series dating, and standard stratigraphic analysis. All four methods agreed. The site was approximately 250,000 years old. The artifacts found there, stone tools, worked bone, material evidence of human activity, were dismissed. The findings were suppressed. SteenmcIntyre's career was effectively ended. The official story held that humans arrived in the Americas no earlier than 12 to 15,000 years ago, and no evidence to the contrary would be permitted to disturb that chronology. We tell you this not because Geological is our subject. We tell you because it establishes something important. The machinery of suppression operates not through conspiracy in the cinematic sense, but through institutional inertia, through the quiet, powerful enforcement of accepted timelines by the bodies that control publication, funding, and professional reputation. Now, the vitrification. Vitrification is the process by which rock or soil is transformed into a glass-like substance through the application of extreme heat. Temperatures above approximately 1200 degrees Celsius higher in some materials are required to produce true vitrification. This is not the heat of a campfire. This is not the heat of a lightning strike. This is industrial heat. Sustained, directed, extreme heat. Vitrified stone has been documented at sites across Scotland, France, parts of the American Southwest, and the Indus Valley. At Scottish Hill Fort, structures like Tapo, Noth and Dun Mac Snick and the stone walls have been vitrified to depths of several feet. The leading archaeological explanation is deliberate firing of timber-laced stone structures. Enemies burned the forts. The heat fused the stone. This explanation has problems. Experiments in deliberate vitrification of hill forts have consistently failed to reproduce the depth and uniformity of vitrification observed at these sites. The temperatures required cannot be sustained long enough by burning timber alone. The vitrification at these sites suggests a heat source more intense than any recorded pre-industrial technology should have produced. But the vitrification at certain mesa formations is stranger still. At several sites in the American Southwest, sites that we will not name specifically because the access has been systematically restricted in recent decades, the exposed surface rock shows vitrification patterns that are not volcanic in origin. The mineralogical signature is wrong for volcanic heat. The vitrification occurs in horizontal bands, not in the irregular patterns that volcanic activity produces. And the bands are level. The same elevation. Site to site. Across geological features separated by hundreds of miles. What natural process produces a level band of vitrification at consistent elevation across disconnected rock formations? The answer the model provides is none. The answer the literature provides is silence. Part 3. The elevation correspondence. There is a phenomenon quietly documented, minimally discussed by surveyors working the Colorado Plateau in the late 19th and early 20th centuries. It appeared again in satellite topographic data processed in the 1990s, and it was flagged internally by at least one geological survey team whose report was classified under administrative rather than scientific rationale. Mesa summits correspond. Not every mesa. Not all of them. But a statistically significant cluster of major mesa formations across the Colorado Plateau Formation separated by distances of 50 to 300 miles share summit elevations within a margin too narrow to be explained by uniform tectonic uplift alone. Let us understand what tectonic uplift means at this scale. When a region undergoes tectonic uplift, when the land rises, it does not rise uniformly. It rises in blocks. It rises with fault lines creating differential elevation. It rises with local variations that produce the irregular, chaotic topography we see in mountain ranges and uplifted plateaus everywhere on Earth. What you do not get from tectonic uplift, across hundreds of miles of complex terrain, is a set of isolated vertical formations that happen to terminate at the same height. You get that from a common original surface. You get that if these formations are not what rises but what remains. This is the interpretive inversion that changes everything. What if the mesas are not columns that survived as the surrounding rock eroded away? What if the surrounding terrain is the original surface level and the mesas represent excavations? What if the flat floor of the desert, the wide basin, the valley, represents material that was removed and the mesas are what was left standing because they were deliberately preserved, or because the removal process stopped there? The geometry supports this interpretation. The angle of the walls, the verticality supports this interpretation. The correspondence of summit elevation supports this interpretation. The vitrification, if it reflects a high-energy removal process, supports this interpretation. What this interpretation requires us to accept is something the official framework cannot accommodate: the prior existence of a civilization, or a technological process, operating at a scale and sophistication that rewrites the timeline of human or pre-human capability on this planet. And here is where we must proceed carefully. Because the evidence is real, and the implications are vast, and the temptation to leap further than the evidence carries is exactly the temptation that discredits legitimate inquiry. So we stay with what is documented. What is measured? What is in the record? Part 4, The Ringing Rocks. In Bucks County, Pennsylvania, there is a field of boulders known as Ringing Rocks Park. When struck with a hammer or another rock, the boulders produce a clear, resonant, bell-like tone. Not all of them. Roughly 30% of the boulders in the field ring. The others are silent. This is not a local curiosity. Ringing rocks or sonorous rocks, in geological terminology, have been documented on every inhabited continent. The Inca used them. The cultures of West Africa used them. Ancient sites in Scandinavia, in India, in the American Southwest include what appear to be deliberately placed or deliberately worked ringing stones. The geology of ringing rocks involves a phenomenon called lithophony. The stones ring because internal stress, residual stress locked into the crystalline structure of the rock during cooling or compression, creates a resonant quality when the stone is vibrated. The specific mechanism is understood. What is less understood is the source and purpose of the internal stress in many of these formations. In naturally formed ringing rocks, the stress typically originates from cooling. Magmatic rocks that cooled under specific pressure conditions retain internal tension that produces resonance. This is documented and reproducible. But certain ringing rock formations, including some associated with mesa structures in the Southwest, show stress patterns that do not correspond to natural cooling. The stress is directional. It has orientation. In some samples, the stress vectors align with the surface geometry of the formation in ways that suggest the stress was applied, not deposited. Applied stress. In rock formations that predate known human civilization. The ringing rocks matter not because they are interesting acoustically. They matter because they represent evidence of material modification, physical change to the internal structure of stone that is difficult to explain within the standard geological model. And they appear, with disproportionate frequency, near the anomalous formations we are examining. Part 5, What the Records Almost Say. In 1871, the Wheeler Survey, one of the 4 great surveys of the American West, produced documentation that has been partially archived, partially reproduced, and partially lost. George Montague Wheeler was a military man. He was mapping territory for the Army Corps of Engineers. He was not looking for anomalies. He was measuring elevation, recording topography, and assessing the terrain for military and administrative utility. His survey notes, for certain sections of the Colorado and New Mexico territories, contain descriptions of formations that he struggled to categorize. He uses the word artificial at least 3 times in surviving documents and then qualifies it, retreats from it, substitutes geological vocabulary. You can almost see the professional pressure in the prose, a man who has seen something, who knows what he has seen, and who does not have the framework or the safety to say it plainly. Artificial is a significant word. It means made. It means constructed. It means not natural. Wheeler was not a mystic. He was an army officer with an engineering education. When he reached for artificial and then pulled back, he was not describing imagination. He was describing something he observed with trained eyes in the field, something that his professional vocabulary could not hold. The Powell Geographic Survey, operating in overlapping territory, produced similar moments of documentary hesitation. Clarence Dutton, one of the most capable geologists of the 19th century, a man whose work on the Grand Canyon remains foundational, wrote in his 1882 monograph Tertiary History of the Grand Canyon District about what he called the problem of the platforms. He identified a class of flat-surfaced horizontal features in the canyon system that he acknowledged could not be fully explained by his erosion model. He dedicated 14 pages to the problem. And then, in a move that reads strangely to modern eyes, he abandoned the thread entirely and moved to a different chapter. 14 pages. Abandoned. Those 14 pages have never been the subject of a dedicated geological study. They have never been followed up. They sit in the archive, in a monograph published in 1882, containing a problem that one of the 19th century's greatest geologists could not solve, and the problem has been left there, quietly, for 140 years. This is not suppression in the dramatic sense. This is something more insidious, the normalization of incompleteness. The institutional habit of moving on. The professional consensus that says, the model works well enough, the anomalies are manageable, the questions we cannot answer are best left unasked. But the rock remembers. The angles remain. The elevations correspond. The vitrification persists. Part 6, the South American Parallel. The tepuis of Venezuela, those extraordinary flat-topped mountains that rise from the rainforest-like ruins of an older world, have fascinated scientists since Alexander von Humboldt first described them in the early 19th century. Mount Roraima, the most famous of them, inspired Arthur Conan Doyle's novel The Lost World. It rises nearly 3,000 meters from the surrounding jungle. Its walls are near vertical sandstone. Its summit is a different ecosystem, entirely cooler, wetter, populated with species found nowhere else on Earth. It has been called, accurately, a world above the world. The geological explanation for the tepuis is the breakup of the ancient supercontinent Gondwana. These formations are remnants of a vast sandstone plateau that covered much of South America before tectonic separation and erosion reduced it. What remains is the hardest, most resistant material. The tepuis are the survivors. This explanation is broadly convincing. It accounts for the distribution of the tepuis, for their composition, for the biological isolation of their summits. But there are aspects of the tepui formation record that the Gondwana model does not address. The walls. The walls of the major tepuis are among the most vertical large-scale rock faces on Earth. Not steep. Vertical. The face of Mount Roraima's prow drops approximately 1,000 meters at close to 90 degrees. Erosion, even differential erosion of the most extreme kind, produces slopes. It produces overhangs, yes. But it produces them through the undercutting of weaker lower strata, which then collapses, which then retreats. The process is intermittent. The result is irregular. What it does not readily produce, over hundreds of millions of years of exposure, is a 1,000-meter face maintained at vertical across its entire height. And there is something else. Something documented in the geological literature of the tepuis that is rarely discussed in popular treatments of these formations. The drainage patterns. Water that falls on the summit of a tepui drains in a specific pattern determined by the microtopography of the summit surface. You would expect, in a natural formation shaped by random erosion over geological time, that this drainage pattern would be irregular, dendritic, branching, chaotic in the way that natural drainage systems are chaotic. The drainage patterns of several major tepuis are not irregular. They are organized. They drain in systems that bear a geometric relationship to the summit's overall shape. They appear, to the trained eye that has looked at enough hydraulic engineering, to be designed. Water, on the summit of Roraima, goes where it is directed. Part 7. The African Formations and the Problem of Age. The Sahara is not ancient in the way we casually assume. 12,000 years ago, a geological eye blink, the Sahara was green. It was a fertile region with lakes, rivers, abundant wildlife, and human habitation. The geological and paleoclimatological record for this is unambiguous. Cave paintings in the Tassili Enajur region of Algeria show cattle, swimmers, human figures engaged in what appear to be ceremonial activities, painted by people who lived in a landscape that the modern Sahara has buried entirely. The transition from the green Sahara to the desert we know today took approximately 2,000 years. In geological terms, this is instantaneous. An entire regional ecosystem was transformed within a timeframe shorter than the interval between ancient Egypt and us. The mesas and plateaus of the Sahara, the Ahaggar Massif, the Tibesti, the Enedi are studied within a geological framework that treats them as static, ancient features of a stable continental crust. And in one sense, they are. The rock is old. The Precambrian basement of the African craton is among the oldest exposed rock on Earth. But the shaping of the surface, the specific geometry of the formations, is not necessarily as old as the rock itself. Surface geometry is a function of what has happened to the rock, not just of what the rock is. And what has happened to the rock in the Sahara within a timeframe that includes human activity includes things the standard model has not fully accounted for. There are formations in the Enedi region of Chad that local traditions describe as constructed. Not shaped by gods in a mythological sense, constructed. The oral traditions of the region, documented by French ethnographers in the mid-20th century, speak of a prior people, not ancestors, but a prior people, distinct and earlier, who worked the stone at a scale that required capabilities no longer present in the world. Oral traditions are not evidence in the scientific sense. They are filtered by time, by cultural transmission, by the imaginative needs of the communities that carry them. We acknowledge this. But oral traditions that describe, independently, across cultures separated by oceans and millennia, the same phenomenon of prior people who worked stone at extraordinary scale deserve to be held alongside the physical evidence, not dismissed because they do not fit within the approved evidentiary categories of modern archaeology. The physical evidence is there. The oral record points to it. The question is whether we are permitted to connect them. Part 8. The Infrastructure Hypothesis. Let us propose a framework. Not a settled conclusion as investigative frame. What if the mesas are remnants of infrastructure? Not infrastructure in the sense of roads or bridges or buildings, infrastructure in a larger sense. Platforms. Elevated surfaces. Terrain modifications made for purposes we do not yet understand, by an agency we cannot yet name, using processes that the geological record preserves but that our interpretive models refuse to recognize. The word infrastructure carries specific connotations. It implies scale. It implies purpose. It implies the expenditure of enormous resources toward a defined goal. and it implies a civilization capable of planning, executing, and sustaining operations at that scale. If the mesas of the Colorado Plateau were infrastructure, if they were cut, leveled, and maintained as elevated platforms across a vast geographic region, then the questions that follow are: who built them? When? For what purpose? And where did they go? The who may be permanently beyond recovery. The biological and cultural record for any civilization operating before the Younger Dryas, before approximately 12,000 years ago, has been largely reset by the catastrophic environmental changes of that period. Ice sheets advanced and retreated. Sea levels changed by over 100 meters. River systems were rerouted. Vast coastal zones were drowned. Whatever existed before the Younger Dryas left no stone cities, no papyri, no coins, only, perhaps, modifications to the stone itself. The when is suggested by the geology. The vitrification, the angular geometry, the elevation correspondences, if these are the product of a single period of modification, that period must have occurred before the geological processes that have since operated on the surface. The formations have been eroding for millions of years by current geological reckoning. But eroding does not mean unmodified at origin. It means the modification is old. How old is a question that requires a different investigative tool than we currently apply. The for what purpose is where the investigation must remain honest about its limits. We can observe the geometry. We can measure the elevations. We can document the material anomalies. We cannot, from physical evidence alone, determine purpose. Purpose requires intent, and intent requires a mind, and the mind that shaped these formations, if a mind shaped them, left no written record that we have found. The where did they go may be the most important question of all. Because civilizations do not simply vanish. They transform. They disperse. They are absorbed, conquered, reduced, and folded into successor cultures that carry fragments of the original knowledge forward, distorted, mythologized, preserved in the stories that every culture tells about the ones who came before. The ones who came before. Every culture has them. Every mythological system on Earth includes a prior age, an earlier time when greater things were possible. When the world was different. When beings of greater capability shaped the Earth in ways that the current inhabitants can only observe and wonder at. We are trained to read these traditions as metaphor. As the human tendency to project grandeur onto the past. As the psychological need for a golden age. But what if some of them are memory? Part 9. The geologists who noticed. They appear throughout the literature, if you read carefully enough. The researchers who noticed something wrong, who pushed against the model, who asked the questions that the institutional framework could not absorb. J. Harlan Bretz, who proposed in 1923 that the channeled scablands of Washington state were created by a catastrophic flood. The geological establishment mocked him for 4 decades. In 1979, he received the Penrose Medal, geology's highest honor. He was 96 years old. He had been right the entire time, and the institution had spent 40 years refusing to hear it. Reginald Daly, who proposed continental drift in 1926 independently of Wegener and was dismissed so comprehensively that he effectively abandoned the argument. Continental drift is now called plate tectonics and is the foundation of all modern geology. Virginia Steen McIntyre, whom we have already mentioned, whose career was destroyed for producing evidence that extended the American archaeological timeline by 2 orders of magnitude. These are not marginal figures. These are accomplished scientists operating within their fields, producing evidence by standard methods, reaching conclusions that the framework could not accommodate and being penalized for it. The penalty is never dramatic. It is not dramatic suppression. It is something quieter and more effective: the withdrawal of funding, the refusal of publication, the absence of tenure, the professional silence that surrounds work that cannot be engaged with honestly because engaging with it honestly would require revising the model. The model is always worth more than the anomaly. Until the anomalies accumulate beyond the model's capacity to absorb them. We are watching that accumulation now. Part 10: The Pattern That Closes. Here is what we know. Not what we speculate, what we know. The mesas of the American Southwest, the tepuis of Venezuela, the plateaus of the Sahara, and comparable formations on every inhabited continent share geometric properties that natural erosion processes do not readily explain. The angles are too sharp. The surfaces are too flat. The walls are too vertical. The summit elevations correspond across distances too great for uniform geological process to account for. The vitrification at certain sites, the heat signature in the stone, reflects thermal events that available natural processes cannot generate at the observed scale, distribution, and uniformity. The documentary record contains, at multiple points across multiple centuries, the hesitation of trained observers, geologists, surveyors, cartographers who noticed what was in front of them and then retreated, professionally, from the implications of what they saw. The oral traditions of the cultures who have lived nearest to these formations consistently describe, in their own frameworks, the prior existence of a different order of capability, a time when the Earth was shaped by forces no longer available. The institutional response to anomalous evidence in geology, as in archaeology, as in biology, as in physics at its margins, has historically been suppression first, integration later, often after the careers of the original researchers have ended. All of this is documented. All of this is in the record. What it adds up to is not a proven alternative history. What it adds up to is a question that the official framework has not answered, has not seriously attempted to answer, and has, through the mechanisms of institutional inertia, actively discouraged anyone from pursuing. The mesas are there. They have always been there. They will be there long after every institution that has explained them incorrectly has itself turned to dust. The question they ask is not going away. Part 11: The View from the Top. There is a mesa in the Four Corners region that the Navajo call by a name that translates, approximately, as the place where the sky was held. It is not the most famous formation in the area. It does not appear on tourist maps. Access is restricted by a combination of tribal land designation and federal land management rules that have made visiting it, in practice, nearly impossible for the last 30 years. Older Navajo accounts recorded in ethnographic surveys from the 1930s and preserved in the archive of the Smithsonian Bureau of American Ethnology describe it as a place of great age and great significance. Not spiritual significance in the way we casually apply that term to indigenous sites, as though the spiritual and the physical can be neatly separated. Significance in the sense of function. The Navajo accounts describe it as a place that was used, that had a purpose, that was known, to the ones who came before, as a location of specific utility. The ethnographers who recorded this in the 1930s noted it briefly and classified it under ceremonial site, which is the default category for anything an indigenous culture considers significant and which the researcher does not have a better category for. But there is a survey note from the same period, a government survey note, filed in the Bureau of Land Management Archive in Albuquerque, not the ethnographic archive, that describes the summit of this mesa in physical terms. Flat. Unusually flat. Surface bearing what the surveyor describes as regular markings of unknown origin. Dimensions of the summit measured and recorded. The surveyor recommends further investigation. No further investigation appears in any subsequent record. The marking description's regular markings are consistent with what other observers have described at anomalous sites across the Southwest, linear features, preserved in the rock surface, that have the appearance of tool marks at scales far larger than any known pre-Columbian technology. We do not tell you this to establish certainty. We tell you this because it is the shape of what the record contains, a pattern of observation, a pattern of restriction, a pattern of institutional incuriosity that is itself a kind of evidence. Not evidence of a specific hidden history. Evidence of a systematic refusal to look. And what you refuse to look at tells you something about what you are afraid to find. Closing, the unanswered geometry. The light falls differently on a mesa than on anything else in the landscape. In the late afternoon, when the sun is low and the shadows are long, the vertical walls cast a darkness that is absolute, not gradated, not diffuse, but sharp-edged in a way that makes the air between the formation and its shadow feel like a boundary. Like a threshold. You can stand at the base of one of these formations and feel, physically, that you are standing beside something that was made. Not by wind, not by water, not by the slow patience of geological time. Made with intention. Made to last. 60 million years, the geologists say. And perhaps they are right about the age of the rock. But the age of the rock and the age of the geometry are not necessarily the same thing. Stone is old. The shaping of stone is a different question. What we are left with, at the end of all of this, is the oldest question in the human record: were we the first? The evidence says no. The evidence says something was here before us, something capable of working at a scale that makes our greatest monuments look like the projects of children. Something that left its geometry in the stone, that fused its presence into the molecular structure of the rock face, that corresponded its platforms across hundreds of miles as if measuring distance were trivial and moving earth were routine. Something that is gone now, or hidden, or transformed into a form we no longer recognize. And the mesas stand. They were standing when the first human eyes looked up at them and felt exactly what you feel now, that familiar, unnameable sense that you are looking at something that was already ancient when the world you know began. That the flat top and the vertical wall and the sharp corner and the level summit are not accidents. That the rock is trying to tell you something. That the geometry is a message written in the only language that survives everything, stone. We do not have the translation. Not yet. Maybe not ever. But the message is there. It has always been there. Waiting, with the patience of something that was built to last, for the question that finally takes it seriously. If what you've heard tonight has left you looking differently at the landscape around you, if the horizon looks less certain than it did an hour ago, then share this with someone who still thinks the official story is the whole story. And stay with us. Because the earth has more buried beneath it than any institution has been willing to admit, and we are only beginning to excavate the record.